Now a small theorem on engineering mechanics. Before I proceed to other numericals of engineering mechanics, the theorem statement is like this: theorem of transmissibility of a force. What it is? It says the point of application of a force may be transmitted along its line of action without changing the effect of the force on the rigid body. Now, in the first diagram here, this rectangular one is a AB is a prismatic bar. Prismatic bar means at all points is area of cross section is same. Means area of cross section here, area of cross section here is the same thing as the area of cross section here. All throughout same, right? At this point is a force F1, at this point is a force F2 at the end B, this is at the end A. The dotted line is the line of action of both the forces which passes along the axis of the bar. Now the theorem says you can transmit this force F2 from this end to this end along the line of action. So F2 arrives here. Similarly, you can transmit this F1 along its line of action to the point B. So F1 arrives here. So in the process, what happens is, in the first case, these two were equal and opposite. Means if this is 5 Newton, if F1 is equal to 5 Newton, F2 is equal to 5 Newton. Since they were acting from opposite directions, so sigma F was equal to 0, means it was in equilibrium. And the case was a case of a state of compression. Look, there it is, the bar is being compressed. Now in the second case, by transmitting the forces F2 from this side to this side, F1 from this side to this side, the situation is like this. It is a state of tension, means the same bar AB is pulled to both sides, so there is a tension, but equilibrium is still maintained because this is equal to this and they are opposite. Now if you consider a point in between this F1 while getting transmitted arrives here, that is same thing as this is F1, and this F2 while transmitted along the dotted line along the line of action arrives here. So now look at the case now. So these are within the it, means this prismatic bar is subjected to internal force, right, within it. So AB is a prismatic bar, means having same cross section at all points. F1, F2, two equal and opposite forces, therefore sigma F is equal to 0. Dotted line is the line of action of F1 and F2. And look at this. This is a rigid body. This point is suppose A, this point is B. F1 is acting here, F2 is acting here as shown. The line of action of this F1 is along this dotted line. The line of action of F2 is along this dotted line. So it is C. The same thing as this, means F1 can be transmitted to the point C, which appears like this, and F2 can also be transmitted to the point C along its line of action. So this can be replaced by this, and again, since these two forces are starting from the same point, you can replace F1 and F2 by their resultant force. You can replace F1, F2 by the resultant force, but acting from the point C, right, which is same thing as this.